So I'm going to talk about open data science education. And I want to cover three main things. First of all, I want to give you an overview of what's happening in online education and online education for data science in specific. Second of all, I want to share some insights, things we've learned building scalable education for data science. And thirdly, I want to look into the future and think about what's missing in online education for data science and what we should be thinking about for the future of data science education. But a quick disclaimer first. This is not going to be an unbiased talk. I'm the CEO of DataCamp. We've built an online interactive learning platform for data science, about 800,000 learners who completed over 50 million exercises. And our training has been used by companies like Airbnb, Deloitte, Wells Fargo, and so on. Right now, we're growing at between 2,000 and 3,000 students every day. So it's fair to say we're the fastest growing data science education company at this point in time. Now, if you want to learn Python, if you want to learn data science, you should be aware that there's two types of visions on online education. On the one hand, you have generic learning platforms like Udacity, Coursera, Pluralsight, Lynda, edX, and so on. And what they do, although they have really good content, they teach a broad range of topics online. And so the technology they're using can be used for any type of online education, whether it's history, data science, web development, language learning, and so on. Then on the other hand, you have companies that are vertically focused. For example, Duolingo. If you want to learn a language, you can go to Duolingo, learn any language you want. And all they think about at Duolingo is how can they build the best learning experience for language learning. Similarly, you have vertically focused education companies in the web dev space, Codecademy, Code School, Treehouse. All they think about is how can we build the best learning experience for web development. And then finally, DataCamp, we're a company that's solely focused on how can we build the best learning experience for data science. And the fact that you're vertically focused as a company has a couple of advantages. Before the internet, before there was any technology, you used to have this trade-off between personalization and scalability when you were thinking about education. So the most personalized learning experience is just a one-on-one tutoring or a mentor, which is a great way to learn, but it doesn't scale at all. And then you have small classroom training, which is somewhat more scalable, and it's somewhat less personalized. And then at the extreme other end of the spectrum, you have scalable ways of learning, online videos, textbooks, and so on. But they're very much not scalable, and they're not adapting to the students. There's no personalization at all taking place. And now we're in a very exciting time, because by being vertically focused, by using technology, you can basically build scalable learning experience that are personalized, that are adapting to the student. And so that's what companies like Duolingo, Codecademy, Code School, Treehouse, and DataCamp are doing. We're building interactive, personalized learning experience that scale. And especially for data science, now that millions of people are getting into this field, it's extremely important. So I want to give you a couple of examples of interactive learning interfaces for those who are unfamiliar with this. This is an example from the Bouquet course from Brian Vandeven from Continuum. And on the left-hand side, you can see some explanation and clear instructions to the student. So here they have to create a column data store and then create a Bouquet plot. And then the students can go into the editor. There is already some code ready. They can basically fill in the blanks, submit their answer, and if they get it right, they get a nice Bouquet plot. So that's amazing. So this is just one of the interfaces we have. I want to show you another one from Code School. Basically a similar setup. You have some instructions. The student here needs to add some stuff to a dictionary. If they then submit their answer and they don't get it right, they get personalized feedback that helps them to find the right solution. And this is really the core of the technology. It's analyzing what students do and then giving personalized instant feedback to students. There's an interesting open source project from Jessica Hamrick from the Jupyter project, NBGrader, which basically uses the same concept. So if you look at the top code chunk, the goal here, so the assignment for the student is to write a function that computes the mean of a list of numbers, x, And you can see the solution there. Obviously, it's just a sum over x divided by the length. And then in the coaching below, you see code that is going to check the student's code. And here it's like a dumbed down, very basic example, just to make the point. But that's really the core of building interactive learning. And I'll come back to the last piece in the next piece of the presentation. But before we continue, I want to give you a sense of the data we've seen and the things we've learned. And although DataCamp is a large sample, we have 800,000 students now. You can ask the question, first of all, before we get into looking at the data, do we have a representative sample? I would argue we have a fairly representative sample because a lot of people find DataCamp by Googling, I want to learn R, learn statistics. So as long as you believe that the group of people Googling for online education in data science is representative for the group of people learning data science, we have a fairly representative sample. So who are these people learning data science? What do they want to learn? And what have we learned teaching? First of all, about 70% of the people learning data science are working professionals. And they typically work in 3 different sectors: technology, finance, and healthcare. We've got users from all of these companies, typically dozens, sometimes hundreds of users. The second thing that's interesting is they're fairly young. 70% of them are younger than 35, and the biggest group is between 25 and 35 years old. And somewhat like this audience, they're male-dominated, so it's about 71% male and about 29% female. Okay, so now that we have a sense of who are these people that want to learn data science, let's look at what do they want to learn. We're going to look at some results from a survey we did. It's a fairly small sample, but the results nicely align with what we see as actual search data on our platform. You can see the results here at the top. People want to learn about machine learning and statistical modeling, which is not really surprising. But thirdly, they want to see case studies. So students really want to understand how they can apply their new knowledge to real-world situations. And then in the 4th position, you see Python programming. I think you need a little bit of context here. Initially, DataCamp started out as an online learning platform solely focused on R. So the fact that people are requesting Python programming is fairly interested. About 40% of our R users are really interested in Python programming. And if you look at the inflow of new students, we see about 50-50 people that want to learn R versus Python, but the group of people that want to learn Python is actually growing faster than the group that's learning R. So even though it's not a race, it looks like Python is winning. And then you see, but it also, in all seriousness, it also confirms what a lot of people have said. A lot of people that are doing data science professionally are using multiple technologies at the same time. And so if people want to learn and get into this field, they are also interested in learning multiple tools. And that's, even though our user base has a very clear preference for stats and machine learning, when we think about building out our curriculum, we really want to cover every aspect of the data science process. So obviously, you need to learn the basics. You need to learn the basics of Python and R. But then we teach you how to import and clean data, how to manipulate data, how to visualize data, and then eventually how to do statistical modeling and machine learning and create reports that communicate the results of your analysis. And I want to introduce a small sales pitch for our Python curriculum. It's really incredible, and we're really proud to have partnered with Continuum Analytics. So we already have Python courses that cover the basics, Intro to Python, Data Science Toolbox. And in collaboration with Continuum, we've developed multiple courses on Pandas. That's David Arulia doing these courses. He's the director of training here. And then we have 2 courses on data visualization, one focused on Matplotlib and Seaborn, and one focused on Bouquet. And these are done by Brian Van de Ven, who's the main author of Bouquet, of course. All right, so we've been teaching data science online for a while, and I want to share a couple of key insights, things we've noticed. So the first thing is, if you think about online education, usually people think about massive open online courses, but the dirty secret is that the completion rates of these courses are very low. A lot of people start open online courses, but very few of them finish them. It's usually below 10%. If you look at DataCamp's free course, we're at like 30%. If you look at the subset of our premium courses, so paying customers, it's between 40 and 75%. So the conclusion is dollars and interactivity correlates with higher engagement. And I would argue for interactivity, it really leads to higher engagement. Because if you look at the data, we see higher drop-off points every time there's a video in a course compared to interactive exercises. I already mentioned that we've also noticed that our users really want Python courses, about 40%. And then finally, something else we've learned is it's really hard to automate the instructor and give really good feedback to students based on what they've done. We're building a Python package, Python what, that basically takes the input of students and then gives sensible feedback to them and tells them if they made a mistake, how they can fix it. If you're interested in that kind of stuff, it's all open source, and you can have a look at the GitHub repo. Now, having said all that, what's the future of data science learning? And maybe to start with, I've been focusing on online education. So the first question is the future of data science learning online? I would argue yes, because if you think about who's learning, they're working professionals, they're very busy, and they're between 25 and 35, most of them. So very few of them are probably going to have the time or the financial means to go back to school. Even if they wanted to do that, we're talking about millions of people here. So there's no way the traditional education system is going to be able to sustain that. So the future of data science learning has to be online, because that's the only thing that's going to scale and that will enable us to train millions of people that are coming into this field. But what I wanted to talk about now, I want to make a case for the importance of fluency. And I want you to think back to when you were learning Spanish. And if you never learned Spanish, maybe think back to when you were learning another language. And if you never learned another language, well, this example is not going to work. But so think about when you were learning Spanish. The first thing you were doing, you were like learning the vocabulary, a couple of basic words. You were learning some of the basic grammatical rules. But then what? You still can't read. You still can't actively make phrases. So the way you really learn a language is by repetition and practice. And that breaks down into two pieces. There's a passive component and there's an active component. If you're learning Spanish, what you're gonna do is you're gonna read the same words and similar sentences over and over again until you get a basic understanding. You're gonna listen to somebody speaking Spanish a lot, and after a while you'll start to understand what they're saying. And then that's the passive fluency component. The second component is active fluency. In order to learn how to speak Spanish, you'll have to do that regularly, and you'll have to repeat the same words in the same sentences over and over again until you get fluent at it. And so think now back about data science education. What online platforms have been doing and the way education has worked so far is we teach people on a step-by-step basis, and then often online you get a course completion certificate. But the only thing you've basically done is you've learned some vocabulary and you've learned some grammatical rules. It doesn't really make you fluent at anything. It doesn't make you ready for the labor market. So these course completion certificates are actually fairly invaluable. What you really need is, once you've learned the basic syntax, is you need, first of all, to train your passive understanding of Python code, say. And then you need to train your active fluency by repetition. And then by doing that, you'll get better and better over time. And we've been working on something in this area quite recently. But so first of all, the point I want to make is to get to actual data science fluency, to get to the point where you're productive, you don't only need the basic learning, you need repetition, and that's what gets you to fluency. So let's have a look at a couple of simple interfaces. If you want to train passive fluency, you can, for example, have an interface that shows you some Python code, and then as a student, you have to match it with the output. And if you do that again, you'll kind of get the hang of it. Then there's another interface that's basically doing the reverse. So you have a piece of output, and you have to understand as a student what chunk of code generated that piece of output. And the goal here is like students can do these challenges very quickly, 20, 30 seconds, and that way they'll train their passive fluency in Python. And then let's move on to active fluency. Here you actually have to fill in specific blocks in a small script. But you're helping the students so they get a couple of potential answers here. So it's somewhere in between passive and active knowledge. And then eventually you want to teach people, obviously, how to write code. So this time you're giving them blocks they have to fill in, and there's no more aid. So our vision is that by focusing on repetition and through repetition, training passive fluency and then active fluency, people will actually get good at something. And then once we get good at understanding what people's fluency level is, and we get good at adapting the learning experience to the level of the student, then we can think about certifying certain levels of data science fluency. And then as an employer, you know that somebody will be able to get something done in a certain amount of time, and not only that they just learned the grammatical rules and the vocabulary. If you want to hire somebody who's going to be interfacing with Spanish clients, you want them to be able to actually speak to them, right? So that's kind of, in a nutshell, the vision for our roadmap for 2017. We want to focus on building a practice mode. We believe that if you focus on repetition to create data science fluency, a mobile interface is going to be really popular. And then we want to use those measures of data science fluency to certify certain levels. And of course, we're going to be building even more Python courses. All right, that's all I've got. Any questions? Yes.
As we heard in other talks, data science is a team sport. But how do you support teaching teams and not single persons to do data science?
Yeah, that's a really good question. So in this presentation, I've focused on solely one aspect of the learning experience, which is getting to fluency, getting to understand and get fluent at the syntax of Python packages, and basic modeling. But it's true, data science is a team sport. And so we do support groups learning on DataCamp, but it's still going to be everybody individually going through the courses. I guess to actually learn how to collaborate in a team, it's also going to be learning by doing. So the best way to learn that is just by being part of a team. I think it's way harder for online education especially to train people in how to collaborate with other people, to be honest. If you have suggestions, I'm definitely open to it. But it's true that that's a really important piece of training productive data scientists as well. I'm not sure online education is the right vehicle to train that. Yes?
In terms of the improve the fluency, is that a good idea? Can you add maybe a kind of term project by the end of one class, and you can assign this project to a team to let a team to finish, from the beginning to the end. And through this way, you can training the teamwork and also how to implement to
Yeah.
solve the practical real world problem.
Yeah. You're absolutely right. Like, doing projects is something else that's on our roadmap as well. We strongly feel like the first thing you need to accomplish, there's a surprising number of people that still has to learn the basics and has to get to some level of fluency. Once you're at some level of fluency, then you want to teach people real-life applications and how to work on them through projects. And that's something else we definitely want to build out in 2017. We already have some case studies courses that focus on that, but there's way more we can do.
Oh, hi. So let's say you're a software developer and maybe you've had like a math background in the past. What's like your method for assessing, I guess, like the prerequisites on that timeline?
We don't have one yet, but so one of the cool things about these types of interfaces is you can use them to assess the skill level of someone. So something we want to do is then assess at what level someone is and advise them what courses they should take. Yeah, we don't have it yet, but it's on our roadmap.
Maybe you went over this in your presentation. Forgive me if you did, but what do you think the current mixture of R and Python courses is?
Sorry, can you speak up?
What's the current mixture of Python versus R that you guys have in your content?
We still are somewhat R dominated, but we're building out the Python courses at a faster rate, or we will be building out the Python courses at a faster rate in 2017. So the goal is by the end of the year to kind of get them to the same level. Does that answer your question? Okay. Anyone else has any questions or comments?
Do you assume a given background, or you're talking about assessing skills? I can see a different track for someone who's coming from, say, being a DBA, who wants to move into data science because they've got some math background. Somebody who's a programmer, as the gentleman over here said, but has some math background, as opposed to maybe your traditional data scientist who is probably an applied math person of some sort and is picking up Python.
Yeah.
Oh, and do you measure the number of people coming in? Like, do you ask what your background is when they come into DataCamp?
So is the question, do we measure the type of person that is coming into DataCamp? Not for everyone. We do regular surveys. I would say in general, the typical person taking training on DataCamp doesn't have a very strong technical background, and they first of all want to learn the basics, and then move into different fields. So it's like there are people with an engineering background taking DataCamp courses, but actually the majority is not like that. So for a lot of people, it's their first programming experience, and maybe they're working with Excel or Tableau or something like that. But they understand that to get ahead in their career or to switch careers, they need to pick up Python and R skills. But we don't formally test people as they come into DataCamp yet. We need one of the interfaces I just showed to be able to do that, and that's why we're working on it.
Hi again. Do you see like any danger to maybe like educating certain people with a certain set of tools, but maybe they don't understand the full implications?
There are certainly dangers, yeah. But it's a very philosophical question. It's also dangerous to teach people how to read, but the majority of people can handle it. So yes, there are dangers, but I think the benefits outweigh the downsides.
I just want to respond quickly. So I also work for this company, DataCamp. To the one question around trying to figure out where to direct somebody, what they need to know. So Jonathan mentioned that one of the things we're very focused on is assessing whether somebody has mastered a particular skill set. That's extremely important, especially for employers. But just as important is identifying when somebody clearly has not mastered a particular skill set or doesn't know something. Whereas the first thing is very useful on the back end, once somebody has been through the curriculum, and now we want to say this person has mastered machine learning in Python. On the front end, what you really want to be able to do is use that same technology to say, this person clearly does not know the basics of data visualization in Python, and therefore, here are 2 or 3 courses that they should take to build that foundational knowledge. So in my mind, it's 2 sides of the same coin, neither side of which is a particularly easy problem to solve. But I think it's fair to say we're pretty focused on both.
Yep, absolutely.
Just said you could probably use data science to solve that problem.
Yeah. Yeah, we're exceptionally data-driven internally. And so one of the key things we look at is course completion rates. And it's incredible how much you can increase course completion rates by looking at the data and perfecting the feedback system, perfecting the way the instructions are giving. And it's interesting that, especially for free courses, if people get stuck in online education and they really don't get it, they leave, and a lot of them don't come back. So also as a business, we have a strong incentive to make sure people finish courses and they get through them.